All right, guys, so now we're going to look at the three types of osmosis, or you're going to have that's in both animal and plant cells. You have isotonic, you have hypertonic, and you also have hypotonic. Okay, now when you have our red blood cells are in an isotonic solution, guys, that's when the concentration of the water and the solute, which is sodium chloride, is the same both inside and outside of the cell. So these are our red blood cells right here. They're round, and of course they're just normal red blood cells, so you're not going to gain or lose water here because the amount of water inside of this red blood cell is going to be the same as it is outside of your cell, because as stated, our red blood cells are in 0.69% saline isotonic, which is isotonic to our red blood cells. So just remember, the solute in the water is the same in the cell as in the solution, which is typically the surroundings outside of our cells. Okay. This right here is a plant cell in an isotonic solution. Okay. So the plant cell here, you can see the cell wall, same concept. If you look inside of your cell, you have your central vacuole, it's fine. You have a few organelles in here because this plant cell has ample enough water both inside and outside of the cell. If you look in your textbooks, there should be a picture of both of these, yes, on page 90 of your textbook. So they're showing you, and if you look at figure 5.13, they're showing you isotonic for both, which is normal for both our red blood cells and a plant cell. Okay, cells neither gain nor lose water. Okay, now we're going to move on. You see, this one is figure 5.13 as well. This is considered a hypertonic solution. Okay, no, a hypotonic solution. I apologize. This is a hypotonic solution right here. Okay, now if a cell is placed in a hypotonic solution, okay, as you can see, it's going to what? Burst. All right, if it's placed in a hypotonic solution. Now, what you're going to have here is the water that's outside of your cells is going to go inside of your cells, okay, because you're going to have a higher concentration of water here and a lower concentration of water inside of your cells. So water is moving from a high concentration to a low concentration, which is going to cause our cells to swell and burst. Now, our red blood cells, the term used to describe that is hemolyze or hemolysis. That's because the cell is gaining too much water, so the cell is going to burst. In plant cells, we call it turgid. Okay, use this to remain turgid. So this is normal turgidity for a plant cell. Now, turgid simply means that the plant cell, okay, is going to, if you look at the central vacuole, the membrane around here, okay, the actual membrane is going to push up against the cell wall of a plant cell, which is turgid, but at the same time, the cell is not going to burst. Why is it not going to burst? Because plants have what you call a cell wall. Okay. Now, the opposite of a turgid plant cell is going to be plasmolyzed or plasmolysis. Remember that for your test, plasmolyzed or plasmolysis, of course, is going to be the opposite of turgid. Now, here, hypertonic. Now, when a red blood cell and a plant cell is placed in a hypertonic solution, it's going to what? Lose water. So with a hypertonic solution, of course, as you can see, the red blood cells are going to shrivel up, or they're going to crenate, okay? Kind of like prunes and raisins when they're placed in a hypertonic solution. Of course, they're going to lose what? Water, and that's how raisins and prunes have that shriveled look to them. Now, the animal cells are going to shrink or crenate, okay? Now, down here, as you can see, This is that term plasmolysis when the plant is losing water. So for example, when you have a plant in your home and it needs to be watered, sometimes it's going to look a little limp. And you're going to kind of know that it needs to be watered. I know I have a plant in my home and it looks, the leaves kind of start shriveling up a little bit and shrinking, and that's when I know that I need to water it because as you can see, this one is a little bit different. The membrane is going to pull away from the cell wall, which is actually here, and the plant cell, the inside. Look at all of this extracellular space around the plasma membrane and the cell wall. That's because the cell is actually what's shrinking or wilting per se, because it's now in a hypertonic solution. And like I said, the plant cell is going to undergo plasmolysis, or it's going to plasmolyze over here. Okay, so that's that. So like for example, if you placed if blood cells are in a hypertonic solution, they're going to what? Shrink, because they're going to what? Lose water, or they're going to, another name for it is crenate for our red blood cell. If a red blood cell is placed in a hypotonic solution, it can swell and it bursts. The term used to describe that is hemolysis. And of course, the same thing with the plant cell. When you place a plant cell in a hypotonic solution, is going to go through turgid or become turgid because the membrane is going to push up against the wall. And of course, if you place a plant cell in a hypertonic solution, is going to go through the process called plasmolysis, because the membrane is going to pull away from the cell wall, which is this green structure right here. Okay, so for example, when you have a plant that's wilting, as I gave you in the example earlier, so once it's wilting and it starts looking normal again and healthy again, that's because a hypotonic environment has been created for that particular plant, and the plant has actually has gained water. Okay, so like I say, a plant cell will not burst because it has a cell wall. Active transport, I don't think active transport is on your exam, or did I go over? Was there anything about active transport? I don't think so, but with active transport, you're going to need energy over here. All right, this is bulk transport right here. That's when you have large molecules that has to be transported across, okay, as seen here. All right, there are two types of endocytosis. Endo means something has got to come into the cell that you need to understand. Two words that are very, very important here are phagocytosis and pinocytosis. Now, when you have phagocytosis, it simply means it's going to take in large particles, or it's going to eat or digest something. A really good example of a phagocytosis in us is our white blood cells. Of course, when something foreign gets into the body, or if red blood cells die and they wear out, the white blood cells are going to engulf them by a process called phagocytosis. Okay. Now, on the opposite side, you have pinocytosis. That's when you're going to take in smaller liquid type molecules, such as water. Okay, and it's going to, this is cell drinking, and phagocytosis simply means cell eating. And that's that. So this is part 3.